Hello Junior Techies, my name is Natasha Barton and today I would like to welcome you to this video on bond energy, bond length and bond order. In this video we will define each of these terms. I will explain to you what each of them are and then we will look at how they relate to each other. Let's hop straight into it. So bond energy is the amount of energy required to break apart 1 mole of molecules in the gaseous phase into their component atoms. Now this can be a bit confusing. Basically what we're saying is when there is a bond, when there are two atoms bonded together, bond energy will tell us how much energy these atoms need to absorb in order to break that bond. We say that bond energy is a quantitative measure of bond strength. So what this means is if you have a high bond energy, if we find a high bond energy, it means that the atoms are bonded very strongly together. Bond length is the average distance between the nuclei of two bonded atoms. So when our two atoms are bonded together, we measure the distance between their nuclei and that gives us the bond length. It basically tells us how far apart the nuclei are. Bond order refers to the number of bonds between two atoms. Bond order is given as numbers 1, 2 or 3, where 1 represents a single bond, 2 is a double bond and 3 is a triple bond. We're going to make use of the bond between two carbon atoms to relate all of these terms. So two carbon atoms can form a single bond, a double bond or a triple bond, as you can see on your screen. So we say the bond order is 1, 2 and 3. We find that as the bond order increases, the bond energy increases. Now of course, if bond energy increases, it means that the bond strength increases. What this means is that a single bond is weaker than a double bond, which is weaker than a triple bond. The triple bond here is the strongest. As the bond order increases, however, we find that the bond length decreases. So the stronger the bond is, in this case, between the same atoms, the closer together they become, and that is why it becomes more and more difficult to break them apart. In general, we can say the more bonds there are between two atoms, the shorter the bond length, the higher the bond energy, and the stronger the bond will be. When we compare atoms or the bonds between atoms that have the same bond order, so all of them have the bond order of 1 or 2 or 3, we can refer to atom size in order to relate bond strength, bond energy and bond length. When you look at the diagrams displayed to the screen, you will see we have carbon bonded to different halogens. In this case, fluorine, being at the top of group 7, is the smallest atom. So you'll notice that because the atom size, the size of fluorine is smaller than that of iodine, the distance between the center, the nucleus of the carbon atom, and fluorine is shorter. We therefore say that as the bond length decreases, or as the atom size decreases, we find that the bond length decreases. Also, as the atom size decreases, we find the bond strength will increase. The atoms are closer together and therefore need more energy in order to break apart. So the bond energy will increase as well as the atom size becomes smaller. In general, we can say the smaller the atoms in a bond are, of course, when we are referring to bonds of exactly the same bond order, the shorter the bond length and the higher the bond energy and the stronger the bond will be. That was a lot to take in. Ladies and gentlemen, we have reached the end of this video. This is the end of the theory videos. So I hope that you will join me in the practice videos that follow. Make sure to download the worksheet and to practice using the worksheet as well. Thank you very much for joining me.